Does my 1000 watt 80 gold plus 90% efficient PSU pull 1111 watts, 1000 watts or 900 watts from my wall receptacle at 100% load? When I plug my 200 watt video card into one of the PCI power connectors, is it pulling 222, 200 or 180 watts from the PSU? Why does my PSU claim 1000 watts continuous and 1100 watts max? Which is it? How many watts can I pull out of this thing?
If it quotes it as 1000 watt with 1100 watt max, this typically means that it will support 1100 watts all the time, but it is not recommended at all and will shorten the life of the unit. It is only rated at 1000 watts and you should never go above that, as much as it supports it, and unless you have many high-end graphics cards, drives and more, you are unlikely to go above 1 kilowatt. When you plug in a 200 watt video card, it will most likely pull about 40 to 50 watt idle and go up to a maximum of 200 watt if used at 100% load, if the specifications say it has a maximum of 200 watt. For the graphics card and the system in general, at 100% load, not the maximum 1100, but the supported max of 1000 watt, will most likely pull about 1100 watts, meaning the system is using 1000 watts along with a further 10% loss as heat. A further example is a 1000 watt machine with 80% efficient means it is 20% inefficient and will pull 1200 watts. So to go back a bit, a 200 watt card will actually pull 220 watts at 90% efficiency. Again, remember, these are the maximums. Machines fluctuate greatly whilst they are on, accessing an optical drive, being idle, moving the mouse, albeit minimal. Anything will change the wattage of the machine.
The efficiency is an extremely complex topic, and in very simple terms Will's answer is correct, but the test specifies following parameters: 87% efficiency at 20% of stated load, 90% efficiency at 50% of stated load, 87% efficiency at 100% of stated load, and power factor of 0.9 at 50% of load. Voltage level is expected to be 115 V. How the power factor part goes into this isn't immediately clear. So what does all of that mean? Well, let's take a look at test protocol. From it we learn that the efficiency is considered ratio between real power provided at device output and real power provided at device input. This is important when calculating whole power consumption of the device. From it we can see that the power factor isn't taken into concern when the efficiency is calculated. So at 50% load, we can more or less accurately calculate total power consumption of the device. First, we say it provides 500 W, then we take efficiency in, so we know that it consumes around 555.56 W of power. At last, we take power factor into equation and we get that it consumes around 617.28 VA, that is the total power consumed by the device. The real power supply consumes is 555.56 W and it also consumes 61.72 VAR, for which you may or may not be charged, depending on the way electricity is sold in your area. We can't be sure what the total power consumption will be at 100% load, because we can't take into effect the power factor which is unknown at the 100% load. I don't think that it will be considerably lower than the on at 50%, and it may be higher. Also, voltage level can make an impact at efficiency of the power supply. Power supplies running at 230 V are usually a bit more efficient than when running at 115 V, but the results will vary from PSU to PSU. Also about the card power consumption. Here, card is considered a separate system and its own efficiency isn't taken into account. Instead, you're provided with its maximum power consumption. So a 200W card will pull up to 200W from the power supply. However, if the power supply is 90% efficient at the moment, you could say that the card will pull 220W from the power plug of the computer plus an unknown number of volt-ampere reactive.
The answer form at Androjaco is very good and detailed, but I feel it is a little complex, so I'll try to answer the question as simple as possible. The important things to know. The 80 Gold Plus rating guarantees a 90% plus efficiency between 20% and 80% of its capacity. The efficiency loss is happening in the transformation of the AC power from the wall to DC power that drives the equipment. A 1000 W rating is the addition of the multiple voltage lines on the PSU. For instance, it may have one 3.3 V line plus one 5 V line plus three 12 V lines that are each rated at 200 W for a total of 1000 W. So it is difficult to draw the exact 1000 W of the PSU, because each accessories may use a different line. But in general you don't have to take care of this when calculating PSU requirements, because you will usually try to match the maximum power usage to 80% to 90% of the capacity of the PSU, hence you have some overhead. Now to answer the exact questions. A 1000 W PSU rated at 90% efficiency at full load will draw 1111 W of 120 VAC from the wall. This 1111 W AC will be converted at 90% to 1000 W DC and the rest will be lost in heat. But remember that it is most likely that efficiency at full load is much lower than 90%. If you plug a 200 W card to the PSU, it will draw 200 W DC from the PSU because there is no loss at this stage as it was converted from AC in the previous calculation. The 1000 continuous and 1100 max means that it is capable of providing 1000 W constantly but will accept spikes up to 1100 W. Such spikes may occur for instance when an optical drive starts to turn or some new devices are connected to USB.
Does my 1000 watt 80 gold plus 90% efficient PSU pull 1111 watts, 1000 watts or 900 watts from my wall receptacle at 100% load? If the efficiency is 90% at full load, 1000 W, the power supply will draw 1111 west from your wall socket. When the power supply states delivered power, they mean the power delivered to the computer components, because the expectation is that your wall socket is more than capable of delivering the required power. That being said, most 80 gold hit their peak efficiency at about 50% load. The unit begins to saturate near full load, and the efficiency typically drops. See this link, click the tech specs for an example. Furthermore, the efficiency is typically a function of the input supply voltage. When I plug my 200 watt video card into one of the PSI power connectors, is it pulling 222, 200 or 180 watts from the PSU? It is pulling 200 W. Whenever we deal with net power delivered from the power supply's perspective, we are talking about how much power the connected components draw. Computer components don't draw enough current to have any substantial losses in the wires. Why does my PSU claim 1000 watts continuous and 1100 watts maximum? Which is it? How many watts can I pull out of this thing? 1100 W is the peak load you can place on the power supply before the unit begins to saturate. Computer power supplies are an example of a switched mode power supply. They basically output a rectified high-frequency waveform and vary the supplied power by varying both the output frequency and duty cycle. When the manufacturer specifies 1100 W as the maximum load, that is the maximum possible power the unit can supply before saturation. Any attempts to draw more than that will simply result in excess losses through heat and inadequate power supply to your computer's components. The voltage levels may rise, fall, damaging your components. Depending on the design of the unit, this may trigger one of the PSU's failure modes, causing it to shut off or blow an internal fuse.
I left the chart